Hello, Algebra 2 Advanced. So today we are going to learn how to graph sine and cosine functions. They are called periodic functions because they represent a cycle that repeats itself, like the cycles of the moon, like tides. They come in, they go out. And because we're going to use the circle, which goes round and round, to find our critical points to graph. So you may also use Desmos in this exploration. I would actually recommend it highly because you can graph several shapes at once, or you can use a slider. So I'm just going to be showing how to do this without any other technology. So the first thing I want to point out is, remember when we talked about the unit circle, we talked about how x goes with cosine, y goes with sine. So to graph, and I'm not a fan of plotting a lot of points, so I'm going to go through and at my quadrantal angles, 0, 90, 180, I'm going to circle my y values. And those are the only points. We're going to go round and round and plot those points. So I notice at 0 radians, sine is 0, so that puts us right here at the origin. Then at pi over 2, my sine value is 1. Sorry, my cat is being really loud. And so I'm going to label my axes. I'm going to put it up here at 1. At pi, I'm back at 0. So there's that idea of cycles. And then at 270, or 3 pi over 2, I'm at negative 1. And then we come full circle, literally, and at 2 pi, I'm back at 0. Now we want to do the same thing if I went in the negative direction. So at negative pi over 2, I'm at a negative 1. I should have labeled that, sorry. Then going backwards to pi, again, I'm at 0. And you sort of just bounce around from 0, 1, 0, negative 1, 0, and then we can connect the dots. And that would be your sine graph. Now something I want to point out in this graph is one cycle is how long it takes to complete the pattern. So this would be, or we could call this one period. So I'm going from 0 and then I hit 0 again. So notice it goes from 0 to 2 pi, which is the same thing as once around the circle, and then the period repeats. There's some technology, some technical issues we'll talk about. This middle line, the x-axis right here, and we'll talk more about these terminologies when we actually do the notes. That's sort of your middle line. It's my favorite word in all of math. It's your sinusoidal axis. You have to say it with a New Jersey accent, which my mom's from New Jersey, so I kind of inherited a little bit of that nasal sinusoidal axis. It's the axis that runs right through the middle, halfway between the highs and the lows. That distance to a high or a low is called the amplitude. It's like how loud is your graph? Okay, and that's what we're going to investigate in this next set of graphs. So you guys are going to use Desmos, and you really should kind of turn this video off and come back to it. But if I were to use Desmos and graph y equals 2 sine x, what you will see is that is going to increase your amplitude so that my graph is still going to follow the same pattern. It'll still be 0 here, but at pi over 2, instead of being at 1, it'll be here at 2. Then we come back to 0, then we go back to negative 2, and my controls are in the way over here. We come out to 2 pi, and the same thing, we come back. And again, you guys should be using Desmos to kind of reinforce this, but what that 2 in front is, it's a vertical dilation. You should be used to that. So it's a vertical dilation, basically. So it stretches or shrinks your graph. So let's also, on the same graph, if I did y equals 1/2 x, So 1/2 would be here, negative 1/2 would be here. So instead, 0 is still 0 because now you're multiplying the y values. So this would then go to 1/2. This will still be at 0, negative 1/2, 0. Same thing as we go through, 1/2, 0. So that would be a vertical shrink by 1/2. Okay? Now, notice we've moved those numbers to inside. So notice up here we said the period of this graph is from 0 to 2 pi. That is a distance of 2 pi. And that's the natural period of the sine graph or cosine graph. If I put that 2 right next to the x, remember it's like putting it inside the parentheses, that's going to represent a horizontal shrink or stretch. Remember, horizontal always works the opposite. So a shrink of this first one, if I were to graph sine 2x, and again, you should use Desmos to see how this works, what this really says is if the natural distance is 2 pi for one cycle, that 2 now for the horizontal says I can complete 2 cycles in 2 pi, which is like saying I can complete 1 cycle in pi, so everything's going to shrink. So I'm still going to be at 0 because you're multiplying the x coordinates now. So this is a horizontal dilation, and remember this is going to be by a factor of 1 over b. So if that number there, if the letter inside was b, so this is going to shrink me by 1/2. So instead of being at 1 at pi over 2, I'm now going to be here half the distance, which is pi over 4. And that means instead of at 0, I'm going to be at pi over 2, and then I'm still going to follow my same pattern. So there's one cycle, and then we just keep repeating the cycle. And so notice I was able to complete 2 cycles within 2 pi. That's what that 2 is actually saying. And if you go the other direction, and I could do it backwards as well, but it's not that important. Here, this is saying I'm going to actually horizontally stretch by a factor of 2. That means instead of doing a full cycle in 2 pi, I'm only going to do half a cycle. So what that means is I'm going to have here would be my 0, and again, you should be using Desmos to kind of map this out. Instead of hitting 1 at pi over 2, I'm going to hit 1 at pi, and then I'll hit 0 out here at 2 pi. So that's only going to show half of a cycle, thus the half. But let's do a full cycle. So that's going to bring me back here and to here. That then would represent a full cycle because I have 1 dip and 1 high, 1 minimum and 1 maximum. Sorry, kind of messed up a little here. There we go. Okay, so the number right next to the x is your horizontal dilation. Now let's talk about domain and range of these. So the domain of a sine graph is going to be all real numbers because it just keeps going on and on. The range, however, the range is based on the radius of the unit circle. Notice your range is the y values. So the range is going to be all the y's between -1 and 1. It'll never go above or below unless you do some sort of a translation or dilation. The amplitude, the basic amplitude of the parent graph is 1, always positive. So this is always going to be positive. We'll talk about when you are flipped over, that would be a reflection. And the basic period in radians will be 2 pi. Okay, so again, your basic sine graph starts at 0, goes to 1, comes back to 0. To get these 5 points, these are the 5 points that I'm going to want to see. The beginning, and then you have the beginning, the end. So this is where you start. This is where you end. This is a halfway point, and these are like quarter points. Okay, this would be like a third quarter way. So everything is equally spaced. You can find all these points by taking averages. All right, that's the sine graph. Now let's do the same thing for a cosine graph. So remember, cosine goes with the x value. So I'm going to circle all our quadrantal values for cosine. And if you think about that sine graph, it started on the sinusoidal axis. So sine starts on the sinusoidal. Cosine, however, at 0 radians starts at 1. It starts high. Then at pi over 2, it's at 0. At pi, it's at -1. And then at 3 pi over 2, back to 0. So notice they always still oscillate between the same points. And then let's carry this backwards. If I was going to negative pi over 2, I'd be back at 0, then down to -1, 0, up at 1. So it kind of looks like, I don't know, those handlebars that, you know, sometimes kids have, or the Harley Davidson motorcycles with those big handlebars, if you just look at half of the graph. So again, here would be one period, which it takes 2 pi to complete one cycle. Cosine starts high, ends high. Also goes between 1 and -1. And so just like with the sine graph, and notice that cosine and sine differ by just pi over 2. Like sine would start on the sinusoidal, so that's why it's cosine. Co means complementary to sine. It differs by just 90 degrees. So let's look at what it looks like if you, again, dilate it with the amplitude. So we were doing before between 1 and -1. So if I have a 2 in front of the whole function, again, remember that's a vertical dilation. And so wherever I was at 1, I'm now going to be at 2. 0 stays 0. -1 becomes -2. We go back to 0. Then we need to adjust. And then this goes back up here. And that would be one cycle with an amplitude of 2. So the sinusoidal axis is still this axis that runs through the middle, and that amplitude from the sinusoidal is a distance of 2. If I, again, put in the 1/2, so that would go to here. So I still start high, go to 0, -1/2, 0, +1/2. That would be your graph. And that would show at least one full cycle. All right. And just like before, if you move that 2 inside the function so that it becomes a horizontal dilation, again, it's going to affect it by the reciprocal. So cosine 2x is actually going to, again, be a shrink so that I will be able to complete a full cycle in just pi. But I'm still going to start high. But now I'm going to hit 0 at pi over 4, then -1 at pi over 2, 0, and pi. And just to show that we could complete 2 cycles in 2 pi. That was crazy, sorry. That went a little bit off the charts. And this one, we're trying to end up here. Wait, there we go. And it's always nice to kind of show that it is a continuous function. It will keep going, so I don't stop right at the dot because I like to show that it's going to keep growing. All right, so that was cosine 2x, and then we want to do cosine 1/2. So the reciprocal, that would be 2, which means I can do only half of a cycle in my 2 pi. So it's going to stretch it by a factor of 2. So I'm still going to start here, and I'm going to be at 0 here, and at 2 pi, I will be here. So we want to take it back so we can see a full cycle. So at negative pi, I will also be at 0, and then this would be -1. So your graph is really going to look like this. And again, you can kind of use Desmos to reinforce that. So my graph got stretched out, and it took, I'm having a moment here because I feel like I did something wrong. Did I stretch it? No, because that's half a cycle and that's a full cycle. I feel like I did it wrong then. No? I don't know. I'm having issues. I'm tired. Sorry. All right. So the domain, just like your sine, is all real. Range, again, it's because of the unit circle. It's going to bounce between 1 and -1. The amplitude is always going to be 1 for the parent graph, and the period for the parent graph is 2 pi, unless you have some sort of a dilation. All right, so there's your kind of, and again, to remember, we just use the quadrantal angles to graph it, and that gets you your basic shape. And now we're going to go into the notes and look at this a little more closely.